temporary connections. Several accidents and near misses were reported which were caused by temporary electrical connections. A flash was observed in a hazardous area when a faulty cable was energized. Another time, a big flash and fire was seen from a starter of a portable pump. A roll of wire kept on top of a portable halogen fitting caught fire when this light was unknowingly kept switched on for a long time. All these incidents were caused from unsafe acts or lack of awareness. These wake-up calls emphasize the importance of establishing strict procedure for connecting temporary power. Consider following points while making temporary connections. Only 24V hand lamps are permitted inside a confined space. Any floodlights shall be provided only through a GFCI. Obtain proper advice ticket from respective department before providing temporary power to portable tools and testing equipments inside a confined space. All portable pumps and cables shall be tested before connecting in the area. Follow KNPC standing instructions on movement and connections for portable pumps and equipments. All defective equipments shall be promptly tagged and kept out of service. Make sure starters and connections of portable pumps comply with KNPC standards for the respective area classification. Make sure of ground continuity for all portable equipments. An external grounding for three-phase equipments is preferred even when 4-core cables are used. Power supply to portable tools shall be connected only through a GFCI. No live power cable shall be laid across a road unless the traffic is completely blocked. Only armored, shielded power cables to be used for providing power to three-phase portable pumps and equipments. All floodlights used for shutdown jobs must be explosion-proof and suitable for the area classification. No power shall be connected to unmanned port cabins and portable tool rooms. All temporary power connections shall be supported by relevant document for this job duly signed by concerned authorities. Key points to remember. Ensure that workers know how to use the electrical equipment safely. Make sure enough sockets are available. Check that socket outlets are not overloaded by using unfused adapters, as this can cause fires. Ensure there are no trailing cables that can cause people to trip or fall. Switch off and unplug appliances before cleaning or adjusting them. Ensure everyone looks for electrical wires, cables or equipment near where they are going to work, and check for signs warning of dangers from electricity, or any other hazard. Checks should be made around the job, and remember that electrical cables may be within walls, floors and ceilings, especially when drilling into these locations, etc. Make sure anyone working with electricity has sufficient skills, knowledge and experience to do so. Incorrectly wiring a plug can be dangerous and lead to fatal accidents or fires. Stop using equipment immediately if it appears to be faulty. Have it checked by a competent person. Ensure any electrical equipment brought to work by employees, or any hired or borrowed, is suitable for use before using it and remains suitable by being maintained as necessary. Consider using a residual current device, RCD, between the electrical supply and the equipment, especially when working outdoors, or within a wet or confined place. CHSE's Electrical Safety at Work Site. Overhead electric lines. Be aware of the dangers of working near or underneath overhead power lines. Electricity can flash over from them, even though machinery or equipment may not touch them. Don't work under them when equipment, e.g. ladders, a crane jib, a tipper lorry body or a scaffold pole, could come within a minimum of 6 meters of a power line without getting advice. Speak to the line owner, e.g. the electricity company, railway company or tram operator, before any work begins. Underground cables. 1. Always assume cables will be present when digging in the street, pavement and/or near buildings. 2. Consult local electricity companies and service plans to identify where cables are located. What affects the flow of electricity? Electricity flows more easily through some materials than others. Some substances such as metals generally offer very little resistance to the flow of electric current and are called conductors. A common but perhaps overlooked conductor is the surface or subsurface of the Earth. Glass, plastic, porcelain, clay, pottery, dry wood, and similar substances generally slow or stop the flow of electricity. They are called insulators. Even air, normally an insulator, can become a conductor, as occurs during an arc or lightning stroke. How does water affect the flow of electricity? Pure water is a poor conductor. But small amounts of impurities in water like salt, acid, solvents, or other materials can turn water itself and substances that generally act as insulators into conductors or better conductors. Dry wood, for example, generally slows or stops the flow of electricity. But when saturated with water, wood turns into a conductor. The same is true of human skin. Dry skin has a fairly high resistance to electric current. But when skin is moist or wet, it acts as a conductor. This means that anyone working with electricity in a damp or wet environment needs to exercise extra caution to prevent electrical hazards. What causes shocks? Electricity travels in closed circuits, normally through a conductor. But sometimes a person's body, an efficient conductor of electricity, mistakenly becomes part of the electric circuit. This can cause an electrical shock. Shocks occur when a person's body completes the current path with both wires of an electric circuit, one wire of an energized circuit and the ground. A metal part that accidentally becomes energized due, for example, to a break in its insulation, or another conductor that is carrying a current. When a person receives a shock, electricity flows between parts of the body or through the body to a ground or the earth. What effect do shocks have on the body? An electric shock can result in anything from a slight tingling sensation to immediate cardiac arrest. The severity depends on the following: the amount of current flowing through the body, the current's path through the body, the length of time the body remains in the circuit, and the current's frequency.
Have you ever thought of all the ways you use electricity? We depend on electricity to light our homes, charge our phones and computers, wash our clothes. It powers our lives. But electricity can also be dangerous, even deadly, when used the wrong way. Keep these electrical safety tips in mind to avoid accidents and injuries. Electricity and liquids do not mix. Never place electronics and appliances near water, like next to the sink or the tub. This tip applies to gaming equipment too. Never place a drink near your gaming console. Spills could result in electric shock. Never climb trees near power lines and electrical equipment. Same goes for kites and drones. Before you fly them, make sure you're far away from any overhead power lines. Never pull a plug from an electrical outlet by its cord. Pull from the plug to avoid potential shock, or ask an adult to help you. Going for a swim? Remember, never swim during stormy weather. If you hear thunder, immediately exit the pool until the storm has passed. These are just a few tips to keep in mind. Remember, electricity is amazing stuff, but you should always play it safe. If you're not sure about something, ask an adult. Want more tips? We're here to help. Contact us to learn more about electrical safety.
Please give comment and suggestions.
Thank you.
Subscribe our YouTube channel and hit the bell icon for more updates. Thank for visit our channel. See you next class.
Thank you.